Safety switches, specifically general duty 30 and 60 amp 240 volt single phase and 3-phase NEMA 3R safety switches can present a hazard. The potential hazard is that the safety switch may continue to supply electricity even after being placed in the off position. This means that even when the handle of the switch is in the off position, the circuit that the switch is supposed to energize may still be energized. This situation creates a significant risk of electric shock or electrocution if someone attempts to work on the circuit believing it to be de-energized. To mitigate this risk, it is crucial to always verify that the power is completely off before working on any electrical circuits. Never rely solely on the position of the safety switch handle. Always use a reliable voltage testing device such as a multimeter or a voltage detector to confirm that no voltage is present on the circuit. Before beginning any electrical work, follow proper lockout-tagout procedures. Lockout-tagout is a safety procedure that ensures that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or servicing work. It requires that all hazardous energy sources are isolated and rendered inoperative before any employee begins work on the equipment. Firstly, identify all energy sources. Before starting any work, identify all potential sources of hazardous energy. This may include electrical, mechanical, hydraulic, pneumatic, chemical, thermal, and other energy sources. Secondly, notify all affected employees. Inform all employees who may be affected by the lockout-tagout procedure. This includes operators, maintenance personnel, and any other individuals who work in the area. Thirdly, shut down the equipment. Turn off the equipment using the normal operating controls. Follow the manufacturer's instructions for proper shutdown procedures. Fourthly, isolate the energy sources. Disconnect or isolate all energy sources that could pose a hazard. This may involve disconnecting electrical power, closing valves on hydraulic or pneumatic lines, or blocking mechanical movement. Fifthly, apply lockout devices. Attach lockout devices to each energy isolating device to prevent it from being turned on or reactivated. Lockout devices may include padlocks, tags, and other physical barriers. Sixthly, apply tagout devices. Attach tagout devices to each lockout device to provide a clear warning that the equipment is locked out and should not be operated. Tagout devices should include the name of the person who applied the lockout-tagout, the date, and the reason for the lockout. Seventhly, verify the isolation. After applying lockout-tagout devices, verify that the equipment is completely de-energized and cannot be restarted. This may involve testing the equipment with a voltage tester or attempting to operate the controls. Eighthly, perform the work. Once the isolation is verified, perform the necessary maintenance or servicing work. Ninthly, remove lockout-tagout devices. After the work is completed, remove the lockout-tagout devices. Ensure that all tools and materials have been removed from the equipment and that all guards and safety devices have been reinstalled. Tenthly, notify affected employees. Inform all affected employees that the lockout-tagout has been removed and that the equipment is ready to be restarted. 11thly, restart the equipment. Restart the equipment following the manufacturer's instructions. Monitor the equipment to ensure that it is operating properly. Specific to electrical safety, use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Always assume that electrical circuits are live until proven otherwise. Double check with a reliable voltage tester before touching any wires or components. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. A qualified electrician has the training, experience, and equipment necessary to work safely on electrical systems. Regular inspections of safety switches are also crucial. Check for any signs of damage, such as cracks, broken handles, or loose wires. If any damage is found, replace the switch immediately. Also, ensure that the switch is properly labeled and that the labels are legible. The label should indicate the voltage and amperage rating of the switch. All electrical work should comply with the National Electrical Code, or NEC. The NEC provides detailed requirements for the safe installation and maintenance of electrical systems. Familiarize yourself with the relevant sections of the NEC before performing any electrical work. Some specific sections of the NEC that may be relevant to safety switches include Article 404, which covers switches, and Article 430, which covers motors, motor circuits, and controllers. The NEC is updated every 3 years, so it is important to make sure you are using the latest edition. Electrical safety is everyone's responsibility. By following these precautions, you can help to prevent electrical accidents and injuries. Remember, when dealing with electricity, safety should always be your top priority. If there is any doubt in your mind about your ability to perform the work safely, call a qualified electrician. It is better to be safe than sorry. If the switch is used in an industrial setting, it is crucial to have a comprehensive electrical safety program in place. This program should include regular training for employees, written safety procedures, and regular inspections of electrical equipment. The program should also address lockout tagout procedures, personal protective equipment, and other relevant safety topics. Furthermore, consider the environment in which the safety switch is installed. If the switch is installed in a damp or corrosive environment, it may require additional protection. NEMA 3R enclosures are designed to provide protection against rain, sleet, and snow. However, they may not be suitable for all environments. If the switch is exposed to harsh chemicals or extreme temperatures, a different type of enclosure may be required. Also, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit in the air. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, wear appropriate personal protective equipment, such as arc-rated clothing and face shields. Also, use caution when working on energized equipment. If possible, de-energize the equipment before working on it. In addition to the above, always be aware of the potential for static electricity. Static electricity can build up on clothing and other objects, and it can discharge when you touch a grounded object. Static electricity can ignite flammable materials and cause electrical shocks. To prevent static electricity, wear clothing made of natural fibers, such as cotton. Also, avoid rubbing your feet on carpets or other surfaces that can generate static electricity. Furthermore, ensure that the safety switch is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The grounding conductor should be properly sized and connected to the switch enclosure and to the grounding electrode system. If the grounding system is not properly installed, it can increase the risk of electrical shock. When selecting a safety switch, choose one that is rated for the voltage and amperage of the circuit that it will be used on. The switch should also be rated for the type of load that it will be controlling, such as a motor or a lighting circuit. Using a switch that is not properly rated can lead to overheating, arcing, and other problems. Also, make sure that the switch is easy to operate. The handle should be easy to grip and turn, and the switch should have a clear indication of the on and off positions. A switch that is difficult to operate can be a safety hazard, especially in an emergency situation. In addition to the above, always be aware of the potential for electromagnetic interference or EMI. EMI is a disturbance that can affect the performance of electronic equipment. EMI can be caused by a variety of sources, such as radio transmitters, cell phones, and electrical equipment. To reduce the risk of EMI, use shielded cables and enclosures. Also, keep electrical equipment away from sensitive electronic devices. Furthermore, ensure that the safety switch is properly installed and maintained. The switch should be installed in a location where it is easily accessible and protected from damage. The switch should also be regularly inspected and maintained to ensure that it is operating properly. A poorly installed or maintained switch can be a safety hazard. In addition to the above, always be aware of the potential for corrosion. Corrosion is the deterioration of a material due to a chemical reaction with its environment. Corrosion can weaken electrical connections and cause equipment to fail. To prevent corrosion, Use corrosion-resistant materials and coatings. Also, keep electrical equipment clean and dry. Furthermore, ensure that the safety switch is properly ventilated. Ventilation helps to prevent the buildup of heat, which can damage electrical equipment. The switch should be installed in a location where there is adequate airflow. Also, make sure that the ventilation openings are not blocked. In addition to the above, always be aware of the potential for vibration. Vibration can loosen electrical connections and cause equipment to fail. To reduce the risk of vibration, use vibration-resistant materials and fasteners. Also, support electrical equipment properly. Furthermore, ensure that the safety switch is properly aligned. Misalignment can put stress on electrical connections and cause equipment to fail. The switch should be aligned so that the contacts are properly engaged. In addition to the above, always be aware of the potential for temperature extremes. Extreme temperatures can damage electrical equipment. To protect against temperature extremes, use equipment that is rated for the expected temperature range. Also, provide insulation or cooling as needed. Furthermore, ensure that the safety switch is properly protected from the weather. Weather can damage electrical equipment and create a safety hazard. The switch should be installed in a weatherproof enclosure. In addition to the above, always be aware of the potential for pests. Pests can damage electrical equipment and create a safety hazard. To protect against pests, seal openings in electrical enclosures. Also, use pest control measures as needed. Furthermore, ensure that the safety switch is properly inspected for damage. Damage can compromise the safety of the switch and create a safety hazard. The switch should be inspected regularly for any signs of damage, such as cracks, broken handles, or loose wires. If any damage is found, replace the switch immediately. Always remember to prioritize safety when working with electrical equipment.